So this video is on the factor label method and the metric system. The factor label method is a way of converting between units within the metric system. It is the method I expect you to use because it is the method that will be used in all subsequent courses as well as my course this year. Now, the first thing we need to understand is a little bit about what the prefixes in the metric system mean, or what is their value. So you'll see here in Table C on your reference table, there are what are called selected prefixes. Now, the understanding, this factor tells you the relative size of something, let's say, that allows you to compare a kilometer to a decimeter or a centimeter. The factor for a kilometer is 10 to the third. What that means is a kilometer is the largest unit here. So the ones at the top are always larger, and the ones at the bottom are always going to be smaller. Well, how much smaller or larger are they? Well, before we do that, let's get one thing out of the way. If there is no prefix, then the factor is going to be 10 to the 0. So a meter is 10 to the 0. Now, what does that actually mean? So let's say you have 1 kilometer. Well, how many meters are in a kilometer? Now, notice I put the 1 from the larger unit. I'm going to do that because there's going to be a lot of meters in a kilometer, or a lot of centimeters in 1 kilometer. So I'm always going to put 1 in front of the bigger unit. So go 1 kilometer is equal to, now a kilometer is at 10 to the third power. It's right here. The meter is at 10 to the 0. Now what this means is the difference between 10 to the 0 and 10 to the third is 10 to the third, or 1,000. And what that means is a kilometer is 1,000 times bigger than a meter, which means 1 kilometer would have 10 to the third meters in it. What if it was 1 kilometer and you wanted to know how many centimeters there were in 1 kilometer? Well, the kilometer is right here. The meter is right here. The centimeter is going to be right here, at 10 to the minus 2. The difference between 10 to the third and 10 to the minus 2 on the number line here is 5 notches on the scale. You're going from here, 1, 2, 3, 4, 5 spaces. So there's 10 to the 5th centimeters in a single kilometer. What if you had 1 millimeter and you wanted to know how many nanometers that was? Well, notice I put the 1 for the millimeter, right? Because that's bigger than a nanometer, because millimeters is here and nanometers is here. Well, a millimeter is at 10 to the minus 3. And a nanometer is at 10 to the minus 9. So how many spaces between that? Well, you can count them, but you can just think of this as a number line if you want. The difference between them is 6 places, meaning a nanometer is 1,000,000 times smaller than a millimeter, or 1 millimeter is equal to 10 to the 6th nanometers. Now, these facts can then be used for conversions in what is called the factor label method. So once we know the relationships between the metric units based upon the prefixes, then we can carry out metric conversions using what is termed the factor label method, and we can build on that with what is called dimensional analysis, but we're not going to get there just yet. Let's start with factor label. There are 3 steps in the factor label method. The first step is to put whatever you're given into scientific notation. The second is to find the equivalence. That means the relationship, let's say in our example here, if we want to convert 72 kilometers into centimeters, how many centimeters are there in a kilometer? And the general rule here is I like to have a large unit get the 1, and I'm going to have a lot of the smaller unit, whatever that is. In this case, it's going to be centimeters. And then I'm going to produce a factor by which I'm going to multiply my original number over here, which will convert. It is a shortcut on really what is using proportions. And these are factor label only works for proportional relationships, like when this doubles, that doubles, when this triples, that triples. So let's start with the first thing. Let's put this in scientific notation. So step number 1, right, we're going to go, that's 7.2 times 10 to the first kilometers. That's step number 1. All right, I'm going to do step number 2 over here on the side because I want to have space to multiply by my factors. So we need to know the relationship between kilometers, okay, and centimeters. And since kilometers is the larger of the two units, we're going to say there is 1 kilometer. And then we need to find out how many centimeters there are in a single kilometer. And there's a lot of centimeters in a kilometer, and you can picture that because, kilometer is like, a little less than half a mile. A centimeter is like the width of my pinky, so I should get a lot of centimeters here, all right? The value for kilometers is 10 to the third. The value for centi is 10 to the minus 2. The difference between those is 10 to the fifth power. So for 1 kilometer, there's 10 to the fifth centimeters. And make sure we're clear on this. If this was kiloliters to to centiliters, or from kilograms to centigrams, the math would be exactly the same, except the M would be replaced with an L or a G. No change here. All right, so this is our equivalence. We've done step number 2. Now step number 3 is to multiply by a factor. So we're going to multiply this by something, and the factor we're going to multiply is going to be a fraction. And we're going to take the two things in our equivalence and put one thing on the top of that factor and one thing on the bottom. The idea is, since they're equal to each other, it's really just like we're multiplying our original number by 1. Because if we put this on the top, let's say, and this on the bottom, and they're over each other, since they're the same thing, it's like having 5 over 5. Or even though the numbers don't look like they're the same, in reality, they're equivalent. They are the same thing. Okay, so here's kind of a weird application of a mathematical concept. All right, the rule is when you multiply a factor, you want to put the unit, that's up here, down here, right? So, and you keep the number that's next to it. So there's no rule as to whether the one goes on the top and the bottom. So don't get caught up in one example and applying that to everything. What's important is the kilometer goes on the bottom here, and that the centimeter goes on the top, and that the 1 that was associated with the kilometer goes here, and the 10 to the fifth goes here. Now, when you finally do this, the good thing is you don't even need a calculator for a metric conversion, because all you need to know is how to do exponent math. Now, the kilometer is here, and the kilometer here, since they're on the top and the bottom, and you really need to think of this as like you're multiplying, there's a 1 down here, so, and you're multiplying this, and, if you had like x times y, x over 1 times y over x, when you multiply that out, you would get, y over y, don't make it look like an x, over 1, which is just equal to y. So when you do this, the kilometers cancel each other out, and you get 7.2, and the 10 to the first and the 10 to the fifth multiply out to make 10 to the sixth. Let's do one more to make sure we understand how this works. So let's say we were given a microgram. Let's say you had 505 grams. And the symbol for that, by the way, is 505. I always don't know how to write this. Okay, I'm terrible at that. Right. So the first step would be to put that into scientific notation. So it'd be like, oh, that's easy enough. That's 5.05 times 10 to the second micrograms. And so now we need to convert that into, let's say we're going to convert that into, let's convert that to centigrams. Okay, so we're going to convert that to centigrams. All right, so we need the relationship between micrograms and centigrams. Now, obviously centigrams are larger, right? So we know that 1 centigram is equal to, and the difference between centi and micro, centi is at 10 to the minus 2, micro is at 10 to the minus 6. The difference between those two, everybody say bless you, is going to be 10 to the fourth power. So for every 1 centigram, there are 10 to the fourth micrograms. And so we put a parentheses right here, and we're going to put, because this is microgram here, we're going to put the micro there. Now, a very important point I'm making with this example. This time, the 10 to the fourth goes on the bottom because this 10 to the fourth micrograms is equal to 1 centigram. If you flipped it, though, that wouldn't be equivalent. So whatever number you have here adjacent to the unit stays adjacent to the unit when you put it into the factor. Now, when you multiply this, the 5.05 stays. But in this case, you have 10 to the second, essentially, divided by 10 to the fourth. And we know that when we do that, we take this 2 and we subtract from it the 4 to get our final exponent. So in this case, the exponent is going to be 10 to the negative 2. And the micrograms is going to cancel. And your final answer will be, in fact, in centigrams.